Thank you. So I was asked by the conference organizers to talk about a case study that deals with the human footprint on terrestrial sediment. So it's a topic that hasn't come up too much at this conference, but I think after you hear a few of these numbers, you'll be impressed at the size of the problem and wonder about its solution with me. So for any of these environmental problems that we've been talking about, I think we can all agree that there's three consecutive approaches that need to take place. We need to assess the scope and nature of the problem. We need to value the economics of both sides of the issue. That's something that is not always done. In other words, mitigation versus business as usual. And we need to develop both short-term and long-term solutions. So the issues that surround terrestrial sediment and the human interaction with that is, here's the first fact. Humans are now the largest force in the movement of sediment on Earth. Maybe you didn't know that. So that's greater than ice, wind, and water. In fact, it's more than all of the world rivers combined. So we move more sediment. We move around 26 gigatons of sediment for our convenience, for our pleasure, and for our needs. So I always am asked this question, so I'm just going to give you the answer. How big is a gigaton? So the Great Wall of China is 6,250 kilometers long. It's about 7 meters high and 5 meters wide, or it's about 0.4 gigatons. So 1 gigaton is about a little more than 2 Great Walls of China. And we move every year 26 gigatons of sediment. So an example of, for our convenience, we put in a big airport off of Hong Kong. We built an island. That's an example for our convenience. For our pleasure, the Palm Islands of Dubai might be a great one. There's around 3 gigatons of sediment there. For our needs, I think we all know this, and that's the land use practices, deforestation for creating cropland or pasture land. But in addition to mobilizing all the sediment, we put it in places that it didn't normally go, and we are now intercepting where it does normally go. So we are building dams, as you know. We build about, number 2 fact that you'll find interesting. We build one very large dam every day, and we've done that for 130 years. So every day there's another large dam being built. And of course that intercepts the sediment, and that affects our coastal zone where it used to go, and our floodplains. Another thing we do that relates to sediment is that we mine these low-lying areas, these deltas, for oil, gas, and water. And I think this is an important point, and that's because I think there's been a slight misplace, and I think I know the reason why, but that's another topic. Worry about global sea level rise. So global sea level rise for the last 10, 15 years is about 3 millimeters per year. And we worry that in 100 years that's going to be 30 centimeters, maybe even a meter. But because of our engineered world, these low-lying areas, these deltas, we're rapidly subsiding them because of the mining of oil, gas, and water. And how fast do we lower these surfaces? Well, in the Yellow River Delta, we are lowering them at around, get this, 240 millimeters a year. So in 4 years, you've got a meter. Jakarta in 35, 40 years, that city's now reached levels of 4 meters below sea level. And this is happening all over the world with these mega deltas, mega cities. The problem is we have 500 million people living on these deltas. They had no say in why the cities got there in the first place. They're great places to put big cities. And they had no say in the interception of sediment that once got to cover these surfaces and keep up with subsidence. So we need to value what these problems are. We need the economics of these sediment-related issues. And that's largely missing from the debate. If you asked almost anyone in this whole mass of great thinkers at this meeting how much a delta is worth, they couldn't tell you that. It's seldom been done. It's seldom been done. You know, the Mississippi Delta, it's expected to disappear largely by 2100. And someone has done one study which says, well, you're going to lose at least $100 billion in ecosystem services. But if you think that's only one delta of maybe the top 100 deltas of the world, and that one didn't have many people living on it except for the oil infrastructure, you can see that we're talking about trillions of dollars at stake. And so this is something that is really missing from this equation. Why wasn't it valued? Why isn't it valued? What are the implications of this valuing? So part of the problem is the people who build these dams, that's all upstream. So the governance of upstream inhabitants really has an impact on the downstream inhabitants. And often they're in a different state or different federal jurisdiction, and so they're not adequately talking to one another. So policies will vary between nations and states, and they should, I guess, because the problems are different. But they all should be designed on best practices and that acknowledge environmental change. And if I can echo what you both have said, policies are only good as their ability to be implemented and upheld. And I think that's a problem that are facing a lot of these communities, because for the way the world has worked out, a lot of poor people are living on the deltas. Thank you.